In this video, we're going to have a look at improper integrals. So to start with, it is very similar to any type of integration you've done to A-level maths. So it's similar in that you add 1 to the power, so it becomes 6x to the minus 1 when you integrate that first term. But then you do also have to divide by that new power, so dividing by minus 1. And then when it comes to that second term, you're adding 1 to the power again, so it becomes 4x to the minus 2. But this time you're dividing by minus 2. Now 4 divided by minus 2 is just minus 2. So it will become minus 2x to the minus 2. But because there was a minus before this whole term, that minus and this minus cancel out to give a positive. So it will become a positive 2x to the power of minus 2. To clean up this first term, you're better off just writing it out as minus 6x to the minus 1. Now that you have that, you want you to find the actual integral between a and 1. If those limits weren't there, just a reminder, you would have to put a plus c at the end. So we're integrating between a and 1. So to start with, we're going to put the upper limit into each value wherever x is. So we're going to have minus 6x to the minus 1, which is just minus 6 over x. So we're going to replace x with a. And then we're going to have plus 2 over x squared. We're going to replace x again with a, so it becomes 2 over a squared. Put that in a close bracket. Take away from that the value that you get when you put x equals 1 into this expression. So this time it will be minus 6 over 1, so just minus 6. And then plus 2 over 1 squared, so plus 2. Now minus 6 plus 2 is equal to minus 4. And when you write this out, it'll become minus 6 over a plus 2 over a squared. But then the minus and the minus 4 will join to give a positive 4. So we're going to write plus 4. That's everything for part I. For part 2, what you can see, the difference is that a is being replaced with infinity. So we're going to apply that here. We're going to say that as a tends to infinity, and then we're going to think about what happens to each term that actually has a in it. Well, this first term, minus 6 over a, you can think about this by substituting a very large number for a into this expression. For example, minus 6 over 999,000 will get you to a number closer and closer to 0, the larger a is. Similarly, when you apply that to 2 over a squared, that gets closer and closer to 0, however large a is. That means that this whole expression will just get closer and closer and just tend towards 4, because this 4 is unaffected as a gets larger and larger. So that's your final answer to this integral for part 2. Hopefully this video made sense. Be sure to leave a like if the video helps and subscribe. I'd appreciate a lot. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.